Hello, good evening. Mm, Maybe 6 days ago, I started to shadow uh, ChatGPT topics by the go video, and mm, I tried to shadow each part and separating a lot of parts. So I forgot to the I forgot the content of the first part and second part. So I'd like to review this video. So let's read aloud one more time from start to end. In this video, we take a look at how ChatGPT works. We learned a lot from making this video. We hope you will learn something too. Let's dive right in. ChatGPT was released on November 13th, 2022. It reached 100 million monthly active users in just 2 months. I forgot to start start my stopwatch. So just 15 minutes. Start. Let's start. It took Instagram 2.5 years to reach the same milestone. This is the fastest growing app in history. How does ChatGPT work? The heart of ChatGPT is an LLM, or a large language model. The default LLM for ChatGPT is GPT 3.5. ChatGPT could also use the latest GPT-4 model, but there is not much technical details on GPT-4 yet for us to talk about. What is a large language model? A large language model is a type of neural network-based model that is trained on massive amounts of text data to understand and generate human languages. The model uses the training data to learn the statistical patterns and relationships between words in the language. Hmm? So far, I am reading aloud and understanding is in parallel, but now this sentence, the model uses the training data to learn the statistical patterns and relationships between words in the language. Uh, I'm not enough to understand understanding speed. So one more time. The model uses the training data to run the statistical patterns, mm, relationships between words in the language. The model uses the training data to learn the statistical patterns and relationships between words in the language. This sentence is a bit long, but the structure is very simple. The model is subject and uses is verb. So the model uses what? The training data. Yes. And to run the statistical, to run. So this is purpose. To run the statistical patterns and relationships between words in the language. So this is structure is very simple. Mm, but I'm not good at catch the meaning of uh, the type of sentence that is subject is the something, not a human. Yeah, or very concrete things. So, for example, s- I I verb, you verb, and people's name verb. This is very mm, easy to easy to understand. But the model, the model, this is abstract. So uh, I'm not good at understanding this sentence. Hmm. This is my drawbacks. Okay, next. And then utilizes this knowledge to predict the subsequent words. And then utilizes. Utilizes is verb. So the model is subject. Utilizes is verb. The model utilizes this knowledge to predict the subsequent words. Utilize is similar to use. This knowledge to predict. Predict means expect. Expect next word. And the subsequent words means following words. Subsequent words, one word at a time. One word at a time. Predict the subsequent words, one word at a time. Next. An LLM is often characterized by its size and the number of parameters it contains. LLM is often characterized, be characterized. This is passive, passive voice. LLM is often characterized by its size and the number of parameters it contains. うん。LLM is, うん、LLM is made by a lot of a lot, much amount of parameters. うん。So, for example, human body is characterized by a lot of cells or DNA. うん。So this sentence is like this. LLM is often characterized by size and the number of parameters it contains. So human body is often characterized by its size and the number of cells it contains. The largest model. The largest model of GPT 3.5 has 175 billion parameters spread across 96 layers in the neural network, making it one of the largest deep learning models ever created. The largest model of GPT 3.5, the biggest model, uh, has 175 billion parameters spread, has spread across 96 layers in the neural network. Uh, Neural network has a lot of layers, and a lot of parameters spread each layers. Injected, maybe. So, as a result, one of the largest deep learning models ever created. So, GPT 3.5 is the largest um, model deep ever created. Next, the input and output, the input and output to the model input, output, uh, input and output to the model are organized by a token. Tokens are numerical representation of words. So model is a function. Function has input data and output data. And in this case, in this ChatGPT case, model needs token input and a token output. Mm. What the token? What about token? Token is a representation, numerical representation of words. So uh, each words, each words can be translated to numerical, mm, like a number. So uh, Apple translate translate to token. This is for example, mm, one. It's very it's this is a example. Apple is one. Red is two. Is translated to three. So apple is red means one, three, two. So this is token. Mm. Or more accurately, parts of the words numbers are used for tokens. Numbers are used for tokens rather than words because they can be processed more efficiently. Mm. Why? Mm, why does it translate? Mm, why can why can words be translated to tokens? Because tokens is more efficiently to process. GPT 3.5 was trained on a large chunk of internet data. Mm. GPT 3.5 was trained, trained. So, mm, child, mm, young football player was trained by football coach, football trainer. GPT 3.5 was trained on a large chunk of internet data. A large chunk of internet data. Uh, a piece of cake are like this. Chunk data, internet data, data's ah, internet data's unit is chunk. So a chunk of data, a large chunk of data. The source data contains 500 billion tokens. Mm. Looking at it another way, the model was trained on hundreds of billions of words. Mm. Tokens is origined by mm, the original of token is words. So the so the model was trained on tokens means the models trained on words. This is same meaning because words can be translated to tokens. Next, the model was trained to predict the next token given a sequence of input tokens. The model was trained to predict the next token given a sequence of input tokens. Given given is provided that the model was trained to predict the next token. This is a purpose to predict the next token. Uh, Before we can say to predict the subsequent words. This is same meaning. To predict the next token given a sequence of input tokens. Given a sequence of input tokens. Hmm. So the model was trained by a sequence of input tokens to predict the next token. Next, it is able to generate text that is structured in a way that is grammatically correct and semantically similar to the internet data it was trained on. It is able to generate text. It is able to generate text. Ah, time up. Hmm. Today, I read aloud only one third of all. Hmm. Hmm. So this training is very helpful and useful to understand, to improve, to to improve my understanding speed. And mm, I'm trying to uh, translate uh, this script to my words. This is challenging for me, but good, uh, very good, very good method, very good practice. Okay. Mm. I'll try to read aloud tomorrow too. Thank you for listening. Thank you for watching today. Let's wrap up. See you by later.